Thanks. Good afternoon, everybody. So I'm a professor here on campus, but also a faculty scientist with LBNL up on the Hill. And we joined forces because we realized LBL knows something about energy, we know something about transportation, and we can actually target this big problem of reducing the environmental footprint and energy footprint of transportation as a system in general. And the other thing we realized is that we need really different type of models in order to do that. And this is an example of what we do, and this is an example from my own research. And with this example, I want to illustrate how we see systems, how we see the integration of systems, and what potential we see in improving them. So we work with a major cell phone operator in the US. And of course, they got data, right? And that data is very similar to what a typical large-scale provider would have, right? They know where their customers are. They know how their customers using their services. And you can build some analytics on top of that. And you can build models that will represent you, every customer, into a model that is privacy-preserving, but at the same time keeps all the essential characteristics of how this particular customer behaves. If your customer is a person living somewhere and working somewhere and moving around the Bay Area in a particular way, you can build a model of this person that will preserve everything you need to know for your end application, preserving privacy. And this is what we did. So we looked at the Bay Area. We looked at all those millions of people moving around. We built a model for each single one of them. It's totally anonymized. And the nice thing about it is that you can sample from this model virtual populations. These virtual populations behave in the same way in terms of their mobility and behaviors of choosing ways to move around as the real population in the area. And you can build scenarios. Okay? What you could do now is you could say, well, let's see how a typical day in the Bay Area look like. Now let's see how a typical day in the Bay Area look like if I cut this bridge for a want. What happens if the weather changes? You got enough data to look into that. You can do behavioral scenarios. You could provide multiple choices. You could build virtual transit lines and see how people will react to that if your models are good enough. All right. Other things you can do. You know exact moments where people are where. You know exact moments of their arrivals and departure. You can forecast these arrivals and departures. You can forecast the electricity demand at the level of neighborhood, a block, a particular building. That's a lot of things you could do. And we're working around that, trying to close this loop, trying to close this control loop to optimize the systems for environmental and energy footprints. Thanks very much.